Hello guys, last video we have discussed how to identify strong acid, strong base, weak acid, weak base. Even we have calculated the pH for the mixture of two strong acids. In this video I am going to continue the topic. I will be talking about mixture of strong base, mixture of strong acid and strong base, how to calculate their pH. And the last part, that how to calculate the pH of mixture of strong acid, descriptions, in the description the link will be provided. If you require, you can refer the earlier video for the pH calculation for the mixture of strong acid. Okay, now we are going to explain how to calculate the pH for the mixture of strong base first. The last videos we have taken some example of the strong base. Example of strong base is sodium hydroxide, potassium hydroxide, cesium hydroxide. All hydroxide of the alkali and alkaline earth metals are considered to be strong base. They completely ionize in water and produces OH minus ions. The reaction is one directional, that's why they are called strong base. Now how to calculate the pH for a mixture of strong base first. Let us consider two strong base 1 and strong base 2. Milli equivalent of the strong base 1 is N1V1 and milli equivalent of the strong base 2 N2V2. Here N is the normality, V is the volume. N is the normality and V is the volume. In the last video also I explained that sometimes question can be given in terms of molarity. If the question is given in terms of molarity, first that molarity you need to convert in terms of normality. And you know that normality is equal to molarity into n factor. If n factor is 1, then normality and molarity both of them are same. But if n factor is not 1, in that case first you need to convert molarity in terms of normality by multiplying with the n factor. N factor means how many OH minus ions a particular base can produced once it dissolves in water. Suppose sodium hydroxide n factor is 1, potassium hydroxide n factor is 1, cesium hydroxide n factor is 1, but if you talk about the magnesium hydroxide, n factor will be 2 because it can produce 2 OH minus ions. Magnesium hydroxide if you dissolve, it will give Mg2 plus twice OH minus. Similarly, if you talk about the aluminum hydroxide, n factor will be 3. Clear? Okay. Suppose strong base 1, strong base 2, milli equivalent is N1V1, milli equivalent N2V2. When two base is mixed, a resulting solution is always basic. Basic means it will have the OH minus ions. Resulting solution will be always basic. The concentration of this OH minus ion is equal to N1V1 plus N2V2 by V1 plus V2. Concentration of this mixture, concentration of these OH minus ions will be the milli equivalent of the first base, milli equivalent of the second base by total volume. Once we know the OH minus concentration, we can calculate the H plus concentration. How? We know that H plus into OH minus is equal to Kw. What is Kw? Ionic product of water. What is the value of Kw? 10 to the power minus 14. Yes? Could you recall? Yes. 10 to the power minus 14. Kw, ionic product of water. The value of Kw is 10 to the power minus 14 at 25 degrees Celsius temperature. If temperature is not mentioned, you need to consider at 25 degrees Celsius. If temperature is mentioned, in that case the values can be different. We know that Kw increases as the temperature increases. Yes. Therefore, if you know the OH minus, we can calculate the H plus. H plus will be what? H plus will be your 10 to the power minus 14 by OH minus concentration. Once we get the H plus concentration, we can calculate the pH. pH is nothing but minus log of H plus concentration. Am I right? Could you follow? First, mixture of two strong bases given, the solution will be basic, therefore solution will have the OH minus concentration. The OH minus concentration will be nothing but N1V1 plus N2V2 by V1 plus V2. Here N is the normality, V is the volume in ml. From that OH minus once calculated, we can calculate the H plus by taking this relation. This relation H plus into OH minus equal to Kw. That's called ionic product of water. The ionic product of water value is 10 to the power minus 14 at 25 degrees Celsius. Therefore, H plus can be calculated. Once H plus is calculated, we can calculate the pH. I can take an example. Suppose sodium hydroxide mixed with your calcium hydroxide. Suppose this is 100 ml. This was 0.1 normality. This is also 100 ml. This is also 0.1 normality. The resulting solution must be basic. Therefore, OH minus concentration is N1 V1 plus N2 V2 by V1 plus V2. What we will get? We will be getting, first case N1 V1 is what? How much? Is 10. Second case also is 10 because already it is given in normality. No need to do anything. 10 divided total volume, that is 200. Therefore, it is getting 20 by 200. There is nothing but 10 to the power minus 1. That is the OH minus concentration. Therefore, H plus concentration, tell me that H plus concentration is nothing but 10 to the power minus 14 by OH minus concentration. That is 10 to the power minus 14 divided by 10 to the power minus 1. That is nothing but 10 to the power minus 13. H plus concentration. Clear? Yes. Therefore, pH equal to minus log of H plus concentration. Put the values. Minus log of 10 to the power minus 13. Therefore, this will become 13. pH will be your 13. Clear? Similarly, if it is given in terms of molarity, first we need to convert in terms of normality. Then we need to calculate the OH minus concentration followed by H plus concentration followed by the pH calculation. Sure? Suppose this is given in terms of molarity. Then what will be the normality? Normality will be your 0.1 into 2. Am I right? Normality is equal to molarity into n factor. How many times I should tell? Yes. Therefore, this is the normality. Therefore, here what will happen? Here will be into 2. Therefore, this will become 30, I suppose. Therefore, this will become 3 by 2 into 10 to the power minus 1. From there, we can calculate the H plus concentration. H plus concentration is nothing but 10 to the power minus 14 divided by OH minus concentration. 10 to the power minus 14 or divided by this. Therefore, divided by 3 by 2, 10 to the power minus 1. Therefore, this will come here 2 by 3, 10 to the power minus 13. Am I right? Yes. Therefore, from here we can calculate the pH. pH equal minus log of H plus concentration. Therefore, minus log of 2 by 3 into 10 to the power minus 13. This will be minus log of 10 to the power minus 13 minus log of 2 minus log of 3. Therefore, this will come here 13 minus log 2 means 0.3010, log 3 means 0.4771. Solve it, you will get the answer. Sure, this is how we can calculate the pH for the mixture of strong base. Let us see the next case. Mixture of strong acid and strong base. Mixture of strong acid and strong base. Very simple. Very simple. When an acid is mixed with a base, what they do? Obviously, they will form the salt. Acid and base, they will not sit ideally. They will react with each other. They will form the salt. When strong acid, strong base are mixed, they will react with each other. They will form the salt. In this case, we can have three possibilities. In this case, we have three possibilities. What is that? We can have three possibilities. Based upon the milli equivalent of strong acid and strong base, we will have three possibilities. We are mixing strong acid with strong base. Suppose milli equivalent is N1 V1, milli equivalent of the strong base is N2 V2. We can have three cases. What are the three cases? Case 1, N1 V1 may be equal to N2 V2. In that case, solution will be neutral. Solution will be neutral. That means pH will be your 7. If the milli equivalent of the strong acid and milli equivalent of the strong base are same, the resulting solution will be neutral. Neutral means pH 7. Case 2, milli equivalent of the acid N1 V1 may be greater than milli equivalent of the base. In that case, what will be the resulting solution? What will be the nature of the resulting solution? Obviously, it will be acidic, because milli equivalent of the acid solution is higher than the milli equivalent of the base solution. The solution will be acidic. Solution will be acidic. Clear? As solution will be the acidic, it will have the H plus concentration. That H plus concentration here will be N1 V1 minus N2 V2 by V1 plus V2. Resulting solution will be acidic. H plus concentration will be N1 V1 minus N2 V2 by total volume, that is V1 plus V2. Once you know the H plus concentration, simple, you can calculate the pH. pH is nothing but minus log of H plus concentration. Sure. This is how we can calculate the pH of a mixture of strong acid and strong base, where the milli equivalent of the acid is higher than that of the milli equivalent of the base. We can have another case. Case 3. Case 3. What can be the case? Can you tell me? Milli equivalent of acid is lower than milli equivalent of the base. In that case, solution will be basic. Solution will be basic. Basic means what ions will be there? OH minus ions will be there. That OH minus ion concentration is equal to N2 V2 minus N1 V1 by V1 plus V2. You need to subtract the smaller value from the larger value. Here N2 V2 is greater than N1 V1. Therefore, resulting solution is basic. Basic means OH minus ion concentration. Concentration of the OH minus will be N2 V2 minus N1 V1. Always you need to subtract the smaller one from the larger value. Once we get the OH minus, we can calculate the H plus concentration. H plus concentration is nothing but Kw by OH minus concentration. And we know Kw is nothing but 10 to the minus 14 by OH minus concentration. Once we get the H plus concentration, what is left? pH calculation. pH is what? pH is nothing but minus log of H plus concentration. This is how we can calculate the pH of mixture of strong acid and strong base. We will have three cases. Milli equivalent of both the acid and base can be same. In that case, solution will be neutral. Milli equivalent of the acid can be higher than the milli equivalent of the base. Solution will be acidic. Milli equivalent of the base can be higher than the milli equivalent of the acid. Solution will be the basic. And once solution is basic, we will have the OH minus concentration. As we will have the OH minus concentration, from this relation we can calculate the H plus concentration, because we need to calculate the pH. Once H plus concentration is calculated, pH is nothing but minus log of H plus concentration. This is how we can calculate pH for the mixture of strong acid and strong base. Clear? Next class, we are going to continue the next case. Okay? Stay tuned for the next pH calculation for strong acid and weak base. Okay? Thank you.